Okay, lesson 2.5, solving problems involving rates of change. We recall that instantaneous rate of change, or IROC, is the slope of the tangent or curve at a point at which we want to find the instantaneous rate of change. And a tangent line is a line which only touches the curve at one point. So let's look at the example we have here. We consider this graph, determine whether the instantaneous rate of change is positive or negative at each of the indicated points. So we have this graph here. We have 4 points, A, B, C, and D, and we want to determine whether the IROC values are going to be positive or negative. So all we have to do is hold a ruler against this to see what the slope would be. So if we had, say, for instance, if I drew a line that was like tangential to the curve at A, you can see that the slope of this line would be negative. So this slope would be negative. Okay, and then at point B, if I were to try and draw a tangent to the curve at B, it would be something like this, and the slope would be positive right here at B, right? So if I were to draw the slope of this line, that would be a positive slope. Similarly, at point C here, if I were to draw a tangent line to the curve at C, that would be a positive slope. And D, just by looking at it, that the line that would be tangential to the curve at point D would have a negative slope. Okay, so we can, and we can also say, let's take these points that are maximums and minimums over here. Let's take this maximum. If we were to draw a tangent to the curve at this maximum point C, what would that look like? Let me close that. Let's say I had to draw tangent line to the curve at that maximum point, the slope would be 0. Similarly, if I did a tangent line to the curve at the minimum point here, the slope would be 0, right? So we can tell that when the function is, the part of the function is decreasing as you go from left to right, the slope is going to be negative. And for the parts of the function where it's increasing as you go from left to right, the slope is going to be positive, or the instantaneous rate of change is going to be positive. And at the maximum and minimum values, the IROC values are going to be 0. So part B of this question asks, estimate the IROC at x equals -3 and at x equals -2. And if you look at the graph here, -3 and +2 are the x values when the minimum and maximum values occur. So you know that the IROC values at those points are going to be 0. So at x equals -3, the instantaneous rate of change is 0. Similarly, at x equals 2, the IROC value is also 0. So x equals -3 is a minimum point. And x equals 2, which is right here, it's a maximum. What type of points exist at -3 and +2? So they are the maximum points. They're also called the turning points. They are turning points when the slope of changes. So you can see that at this point here, which is the turning point, the slope changes from being negative to positive, right? So they are turning points. When the slope or the rate of change I'll spell that. When the rate of change shifts from negative to positive, or vice versa, the other way around. So what do you remember about the intervals of increase and decrease? Well, you can tell at an interval of decrease, which is happening here, the IROC values are going to be negative. At intervals of increase, the IROC values are going to be positive. Here we have fill in the blanks. The instantaneous rate of change is 0 at both the maximum and the minimum point. We just saw that. What type of tangent is drawn at a maximum or minimum point? As a curve increases, the slopes of tangent of the curve are on this interval. As the curve decreases, the slopes of the tangent of the curve are on this interval. At a maximum point, the slopes of the tangents must change from positive to negative. And we can see that in our diagram here. We have a maximum point and the slopes of the tangent lines go from positive to negative. And at a minimum point, which you can see here, the slopes go from negative to positive. Okay, we have an example here. For the function f of x equals x cubed minus 27x plus 1, verify that the point -3, 55 is either a maximum or a minimum. So it doesn't ask us if it is a maximum or a minimum. It's just that it is either of those two or either of those two. So if it is either of those two, basically we are trying to verify that at this point the IROC is 0. Okay, so the instantaneous rate of change is 0 at either a maximum or a minimum point. Okay, so let's try to find out what the IROC is at x equals -3. So let's find, or let's determine the IROC, the instantaneous rate of change, at x equals -3 and see what happens. We can try the squeezing method or midpoint interval method. So let's take a value just before -3 and a value just after -3, and then get closer and closer to it in every succeeding interval that we take. So let's start with -3.1, which is the left of -3, and -2.9, just to the right of -3, and find the IROC values there. So it'll be h at -2.9 minus h at -3.1 divided by -2.9 minus -3.1. Okay, so pay attention to those double negatives that happen here and plug those values into this equation for the function. And I've already done it before. I would ask you to pause at this point and see that you're also getting these same values so you can practice using them on your calculator. So this works out to 54.999 minus 54.999 and it doesn't matter what we get over here, -2.9 plus 3.1. We know that the numerator works out to 0, so you can see that the IROC is 0, very close to -3. Actually, we get 0.01 here. Let's now get, squeeze an interval even further closer to 3 and go from -3.01 to -2.99. So it's even smaller intervals than what we have over here. And find the IROC. So the IROC would be h at -2.99 minus h at -3.01 divided by -2.99 minus -3.01. I'm going to pause and work this out to see that you're getting the same answer, which in this case works out exactly to 0. We can even try another interval even closer, just even though we've got to 0, let's just make it even smaller. Let's go from -3.001 and -2.999. And the IROC is h at -2.999 minus h at -3.001 divided by 0.002. And we know that that also actually will work out to 0. So we know that, therefore, the instantaneous rate of change at x equals -3 is 0, and therefore -3 comma 55 is either a maximum or a minimum point. Okay. And our last example for this lesson, we have a word problem. A football is kicked into the air such that its height h in meters after t seconds can be modeled by the function h at t equals -4.9 t squared plus 26.95 t plus 152. A, find the time when the football reaches its maximum height. And B, use the slopes of tangents to verify that this point is a maximum. So the first one is actually something we would have done in grade 10. We are given the function representing, the height of the football as a function of time. So h of t is -4.9 t squared plus 26.95 t plus 152. So if we were to draw a rough sketch of this, it would be something like this. So it's going up, it's being kicked up, coming back down. The y-intercept is 152. We're trying to find the height, the time at maximum height. So we're trying to find this, right? We don't know what the time is, but we can. This would be also the vertex. So if we can find the vertex of this parabola, we can find the time at the maximum height. This is given to us in standard form, so to convert it to the vertex form, we can just complete the square. So we factor out -4.9, and into brackets would go t squared. So you want to get a plus, so this should be minus. Divide 26.95 by 4.9, and we get 5.5 t plus 152. You want to create a perfect square trinomial here. So t squared minus 5.5t, and you divide 5.5 by 2, and then you add and subtract the square of that. So 2.75 squared minus 2.75 squared plus 152. So now, when we did that, these three will form our perfect square trinomial. So it can be written as the square of t minus 2.75 squared. And then we got to remove this out of the brackets. When we take this out, square it, multiply it with -4.9, we get plus 37.05625 plus 152. And we're just going to get now the answer in vertex form, t minus 2.75 squared plus 189.06. So you can easily see the vertex now. The vertex is 2.75 comma 189.06. So that's the height, that's a time, and that's the height or maximum height. Okay, so therefore the time, they didn't ask us maximum height, but we also have that value needed. So the time at maximum height is 2.75 seconds. This time is in seconds. Part B, they're asking us to verify that it is a maximum point, that this point is a maximum point. So in order to verify it's a maximum point, we can find the tangent, the slope of the tangent to curve just before it, and the slope of the tangent to curve just after it, and we can prove that it's gone from a positive to a negative, then this point is a maximum, right? So that's what we're going to do. For part B, we will use the averaging method, or the to find the IROC. So we're going to take intervals just before take an interval just before 2.75 and find the IROC there, and then find an interval just after 2.75 and find the IROC there. And if you can show that this is going from positive to negative, then it's definitely a maximum point. So let's take an interval between 2.7 and 2.75. So that's an interval just before 2.75, and find delta H over delta T. That works to H of 2.75 minus H of 2.7 divided by 0.05, and that works out to 189.05625 minus 189.044 divided by 0.5, which works out to 0.245. So our slope here, or our rate of change, is positive. And then we take an interval just after 2.75. So between 2.75 and 2.8, and find the delta H over delta T. So that would be H at 2.8 minus H at 2.75 divided by 2.8 minus 2.75. And we find that that is 189.044 minus 189.05625 divided by 0.05. And that works out to negative 0.245, and we see that our slope is now negative. So now, therefore, since the rate of change goes from positive to negative, the point or the vertex is a maximum. Okay. So if we were just to use a software to graph, you will see that we found the IROC at just before 2.75. This is our 2.75. And then we found the IROC just after 2.75. So at 2.75, the slope is 0. So this is values of the IROC generated using a software. You can see that they're all positive before it reaches 2.75. And after 2.75, they're all negative. So the rate of change is going from positive to negative, which establishes that 2.75 is a maximum. Okay, now we can practice our question.